Welcome back. Today's goal of this lecture. Today I will see class equation of a group. Class equation of a group means actually the partition of a group. How many partition of a group exist? This is. And there exist many rules which I have discussed in my previous video. Shortly, today I will discuss briefly. At first I will see center and centralizer. Center and centralizer means we all of us know. Center means set of those elements in the group G such that Ax equal to xa, and this is true for all A belongs to G. Set of those elements which commute every element of the group. And centralizer of A means set of those elements in the group G. This is commutes only the point, particular point A. Here the difference. Here this is commute whole point in the group. Set of those elements which commute whole point in the group. But here this is commute only particular point. So always ZG contain in centralizer of A, because centralizer of A means set of those elements which commute only the particular element A. But center means set of those elements which commute whole element of the group G. If X equal to ZG, that means Gx equal to Xg, and this is true for all G be the member of the group G. And in particular for G equal to A, we get A equal to Ax. This is imply from this line. This is imply X belongs to C of A. That means X belongs to centralizer of A. That imply. Here I have considered X equal to ZG, and here also I have got X belongs to C of A. That means ZG contain C of A. And actual important theorem of class equation. Today's goal of this lecture. Today I will see how we will find any class equation of a group. Because what is the class equation? Definition of class equation. This is I had discussed in my previous video. If you don't see it, at first see my previous video. I have given the link in my playlist. The theorem is how we will find the class equation of a group. Let G be a finite group and A be the member of G. The class of A equal to order of G index Ca. That means order of conjugacy class of A is index of Ca in the group G. That means number of coset of Ca in G is actually the class of A. Because this is means mod G over Ca, where C of A is the centralizer of the element A. So order of conjugacy class of A is actually index of Ca in G. That means number of coset of Ca in G is actually the class. This idea, actually class of A always divides the order of the group G, because class of A equal to index of G, index of Ca in G. That means order of class of A equal to order of G divided by order of conjugacy class of A. That means order of class of A times order of conjugacy class of A means order of G. And from this line we can tell order of class of A always divide order of the group G. So if G be a finite group and A1, A2, An are distinct element in the group, then class of A1, class of A2, class of An are distinct element in the group G. then G equal to union of those class of AI, and order of G equal to A in ZG, order of those class of A plus A which not belongs to ZG, order of class of A. That means this is actually order of ZG, and this is when A not belongs to ZG, then order of class of A means order of G divided by order of conjugacy class of A. This is the class equation. That means class of A equation of the group means that is actually partition. This is the element of ZG. Other is this type of coset. Because we all of us know this is actually number of coset of centralizer of A, and this is the class equation of the group G. And when the group is abelian, then ZG, order of ZG equal to whole group, order of the group, then order of G, class equation, then class equation of the group is actually order of ZG. Only order of ZG when the group is abelian. That means if A belongs to ZG, then class of A equal to singleton set A. Because when the member is contained in ZG, then their class contain only this single element. If B1, B2 up to Bn belongs to ZG, then since B1 belongs to ZG, that means class of B1 equal to only the element contain B1. Therefore, ZG equal to B1 class union B2 class union Bn class. And this union is B1, B2 up to Bn, which is equal to ZG. And if P belongs to A minus ZG, that means if P belongs to here, then class of P contain multi-membered elements. When contain ZG, then this is only contain single element. But when contain A minus ZG, then if P belongs to A minus ZG, that implies class of P contain multi-membered elements. For the element G minus ZG, if C1, C2, Cm be the element of G minus ZG, then G minus ZG equal to C1 union C2 union Cm, where Ci is the class of Ai, where Ai belongs to G minus ZG, and class of Ai is G index C of Ai. This is actually the order of conjugacy class of A. This is actually index of Ca in the group G. That means number of coset of Ca in the group G. That means G equal to ZG union G minus ZG, and ZG contain this single element B1 union B2 union ... Bn, and G minus ZG contain C1 union C2 union Cm. This is equal to ZG union C1 union C2 union C union Cm, and order of G we can write this as order of ZG plus order of C1 plus order of C2 up to order of Cm, and this is actually I equal to 1 to m order of Ci, and this is the class equation of group theory. Order of G equal to order of ZG plus this quotient. This is the class equation in the group theory. Now let's see some example, then you will understand in better way. As for example, first, when P is a prime number, then if order of G equal to P, since P is a prime number, so order of G equal to P means G is a cyclic group, and cyclic implies G is a abelian group. That means here the class equation would be order of G equal to 1 plus 1 plus 1 plus 1. This is P times. First, know any group of order P square where P is a prime number, this implies G is an abelian group. That implies since G is abelian, any group of order P square, this would be 1 plus 1 plus 1 up to P square times. If order of G equal to PQ, when P is a prime number, order of G equal to P cube means when the group either this is abelian or this is non-abelian. When abelian, then obviously this group would be 1 plus 1 plus 1 P square times, but when P cube is non-abelian, then this is very interesting. Order of ZG would be, since order of ZG always divide the group G, so possibility of order of ZG either 1 or P square or P cube. Notice here order of ZG equal to 1. This is not possible. We all of us know when the group of order P cube, then always ZG would be greater than 1. Another possibility, since 1 not possible, another possibility either P or P square. P cube not possible. When order of ZG equal to order of whole group, then obviously this is imply the group is abelian. But here given the group is non-abelian, so P cube not possible. Only possibility is either P or P square. If we consider order of ZG equal to P square, we all of us know this theorem. Order of G over ZG. If this quotient group is cyclic, that implies the group G is abelian. When ZG equal to P square, then that implies order of P cube over P square. This group is isomorphic to group of order P, and any group of order P where P is a prime, this is always cyclic. And when the group is cyclic, that implies the group G is abelian. Since here the group of order is PQ, order of G equal to PQ, that implies always the group is abelian. But here given The group is non-abelian. So Zg equal to p square. This is not possible. That means only possibility is Zg equal to p. That means the class equation would be, that means when order of G equal to p cube, that means G is non-abelian, then order of G equal to Zg plus when A does not belongs to Zc, then order of G divided by conjugacy class of A, centralizer of A. And this is equal to, since I have got Zg equal to p times, then that means 1 plus 1 plus 1, this would be plus 1, p times plus p plus up to p, this would be p square minus 1 times. Okay. One example. Consider group of order 8. When the group of order 2 cube, then we all of us know this is one isomorphic to Z8, another isomorphic to Z2 cross Z2 cross Z2, and non-abelian group is V4, means Killenford group. Here the question, when Killenford group means non-abelian, then what is the class? First no, center of Q8 is 1 and minus 1. So order of center of Q8 is 2 and centralizer of I is I equal to set containing the element 1 minus 1 I minus I. So order of Ci is 4. Similarly order of Cj equal to 1 minus 1 j minus j. So order of Cj equal to 4. Centralizer of K is 1 minus 1 K minus K, since similarly order of Ck equal to 4. So order of G equal to, we all of us know Zg plus when A does not belongs to Zg, order of G divided by C of A, and this is equal to, since ZQ8 contain 1 and minus 1, that means ZQ8 contain 2 element, that means this is would be 1 plus 1, other order of G divided by C of A. There that means order of G equal to 8, 8 over 4 equal to 2, 8 similarly 8 over 4 equal to 2, 8 over 4 equal to 2. This value would be 1 plus 2 plus 2. This is the class equation of Killenford group, 8 equal to 1 plus 1 plus 2 plus 2. I will say which of the following cannot be class equation of a group. Option 1, 10 equal to 1 plus 1 plus 1 plus 2 plus 5. Notice here 1 plus 1 means Zg equal to, order of Zg equal to 3. And here 3 divide 10. We all of us know order of Zg always divide the group, but here 3 does not divide 10 because order of Zg equal to 3. So this cannot be class equation, so option 1 is the right option. Second, 8 equal to 1 plus 1 plus 3 plus 3. Here order of Zg equal to 2 and 2 divide 8. But conjugacy class of element, this is also divide the order of the group. But here 3 does not divide 8. So this is also cannot be class equation. Second, here 4 equal to 1 plus 1 plus 2. Here all elements divide the group. If order of Zg equal to 2, that means we all of us know this theorem few minutes ago I had seen. Order of G over Zg, here order of G means 4 and order of Zg is 2, which is isomorphic to Z2. If this is cyclic, order of Zg, G over Zg is cyclic, that imply G is abelian. But when the group is abelian, then only class equation group of order 4 type would be 1 plus 1 plus 1 plus 1. But here given class equation 1 plus 1 plus 2. This is also not possible. So this is right option. Fourth option, 6 equal to 1 plus 2 plus 3. This is possible because here we all of us know up to isomorphism there exists one non-abelian group of order 6. This is S3. And class equation of any permutation group would be same cycle type. And in S3, one identity cycle exists, one 2 cycle exists, and another 3 cycle exists. So, in my next video, I will say the class equation of permutation group Sn is same cycle type equation. Same cycle type with the class equation of any symmetric group. So option 4 is the right option. So option 4 cannot be correct option. This is with the class equation of order 6. Okay. I will stop here. In my next video, I will discuss different type of question of class equation. Because class equation, how we have to find the class equation, this is very important for any competitive exam. Okay. See you soon. Stay safe and stay positive always. Don't forget to subscribe my channel for more videos. Thank you so much.